Okay, this exam problem from exam 2 is a truss problem, but it's also a static equilibrium problem. So I like that, it's two things at once. Okay, so the first thing we're asked to do here is to draw a free body diagram of the entire truss structure. Okay, so I can reproduce this by redrawing it a little bit. Okay, so we have from B to A, and then A to C, and then C to B, all right? And we have a force acting down as shown in the original figure. And then at point A here, we have a pin, all right? So we can draw that pin, label that point A, and we know that there's a force that we can draw in the Y direction, and there's a force that we can draw in the X direction. I don't care which direction those go because the signs would take care of themselves. All right, so this would work. All right, and then C is a roller, and so there's a force only in the Y direction for the force at C. All right, so this is the letter C. This is the force at C. I could call this the force in the Y direction and the force in the AX direction. All right, so there we have it. There's a free body diagram of the entire structure of the truss. Okay, then we can look at only joint B. Joint B is right here, so let me change the color to, say, green. All right, so at joint B, we have a force acting down, and then we have forces from the members that are pulling on joint B. Okay, so I'm going to draw these members in tension. That's the method I've used in class, and if the signs turn out to be negative, we know they're actually in compression. Okay, so this is 600 pounds. And then we can call this the force BC, and this is the force AB. All right, so there's the free body diagram of just joint B. All right, so on a lot of exam problems, I try to give you something easy to do. I think the free body diagrams in general are pretty straightforward, so be sure you collect the points on those. All right, now the next part says calculate the forces associated with the members AB and BC. All right, so if I look at this, I can think of it as a method of joints problem, okay? And with a method of joints problem, if I have two unknown forces at a joint, okay, and here's this third force, that's known, all right? So if I have two unknowns at the joint, I can solve for those unknowns because I can write sort of static equilibrium equations for joint B in the X direction and in the Y direction. Okay, so when you're studying for the exam, think about, how would you solve this and how would I apply it to a slightly different problem? And so that's the idea. Look for, if I give you a truss problem, you're looking for joints where there's two forces unknown. And once I know that, I know I can solve it. All right, so let's go to the solution. Change the color to blue. All right, so we're going to look at the sum of forces in the X direction, and I'm going to need to know some angles. All right, so I can go here and I see I have some dimensions. This horizontal distance here is 1.5 feet. Okay, and this vertical distance is 3 feet. So that would let me calculate this angle alpha. All right, so alpha would be the arctan. Okay, of opposite. Okay, the opposite would be 3, and the adjacent would be 0 or 1.5. Let me make sure I call that alpha. I think I called it theta. Okay, so let me change that so it's consistent with the Matlab solution that I included, just so that you'd know exactly the calculations that you need to make. Okay, so let's call that theta, and this would also be theta. Okay, so the other angle we would need would be angle alpha. All right, so angle alpha would be here. Okay, and I can get that because I know this height is 3, and then this run. All right, if this total is 6.5 and I subtract 1.5, I know that run is that difference. Okay. All right, so this would be the arctan of 3 divided by 6.5 minus 1.5. Okay, so that would be 4. All right, so from there, we know the angles theta and we know alpha. We're feeling good about that. All right, so now let's look at sum of forces in the x direction and sum those to be 0, where x is referenced to the right. Okay, so these are the things I'm looking for when I grade the problem. All right, so I'm looking at this. The 600-pound force is moving complete in the vertical direction, so that is not included. All right, then the AB force is moving back to the left, so it gets a minus sign. And then I use trig. Okay, so I project this the horizontal distance down, so this would be minus AB cosine of alpha. All right, so that takes care of the AB force in the x direction. All right, and then the BC direction acts in the positive direction, right? It's pushing here or it's in tension here to the right is what that's shown as. All right, so it would be plus BC, all right, cosine of theta. That's all the forces in the x direction, so equals 0. All right, so now I'm thinking, as I'm working this problem, what do I know and what do I not know? I know theta and I know alpha. I don't know AB and I don't know BC, but that's okay. I still have one more equation I can write. Sum of forces in the y direction is equal to 0. All right, so I'm going to put up as positive. All right, so I look at the free body diagram and I see minus 600, okay, and then minus AB sine, because it's opposite over adjacent, okay, and I'm looking for the vertical distance, so it'd be sine of alpha minus BC sine of theta. BC is also acting down, equal to 0. Okay, so now I have 2 equations, 2 unknowns, and your task is to solve those. All right, so you can do that in a number of ways. You can do elimination, you can do substitution, you can use Cramer's rule, but at this point it just becomes solving these equations. All right, so I'm not going to cover that part because I feel like solving is something you already know how to do. All right, but I did include the Matlab code so you can see these are the equations I wrote: minus AB cosine alpha plus BC cosine theta. Same here for the next equation. You solve these and you get minus 269 for AB, minus 516 for BC. Remember, these were shown pulling away from the joint. The arrows in the free body diagram are away from the joint. Okay, so the answers are that AB is going to be minus 269, so that'd be 269 pound force in compression. Compression. Okay, because I dropped the minus sign and changed the interpretation of tension to compression. All right, and then BC is going to be 516 pound force in also compression. Okay, and then when I'm taking an exam like this, I would go back and say, does that make sense? And I look at this and yes, if I push this 600-pound force down, I would expect that those 2 members, BC and AB, to be in compression. Okay, and so I'm feeling good about the math and how it worked out on this problem.